All right, good morning. Welcome back. Let's start. First of all, let's look at the schedule really quick. Today we're going to finish up what we were talking about on Friday, and then I'm going to give you a little bit of a project that we're going to work on, and basically we're done with Chapter 1. So starting on Wednesday, notice there's 4 sections of Chapter 2, and we're just going to spend one day on each, and then another project day and a review day, blah, blah, blah. So Chapter 1 and 2 test October 4th, but you guys can follow this schedule on your own as you get going. I want to pick up where we left off, where we had these 4 blue points, A, B, C, and D, and we were trying to get that line that would perfectly go through there, and we were massaging the M and the B, right? The slope and the y-intercept, trying to just get it just right. And I think I told you 1.712 was about as low as you could get that number. You could see I was kind of a failure. I was tinkering with it earlier. I could only get it to 1.747. Gage said he got to 1.712. Did anybody else get it there?
1.71186.
Oh, so even lower than that, and it rounds up to 1.712. Okay, very nice. Did anybody get at least around 1.75 or something like that? 2.4. Yeah, and the idea of this part of the activity wasn't to see if you could get it exact. If we were going to sit here with our eyeballs and try to move this M and move this B forever to get it exact, then we wouldn't really be using technology the way that this awesome piece of software was built. I wanted you to just go through that exercise so you could kind of feel that what we're going to do in a minute, you can see what the computer or the calculator is doing in the background. They're getting these lines, the squares of these lines, as small as possible and adding them all up. It's what we call least squares regression. And there's a way to calculate this by hand, but we are not doing that in this class. It's a real awful, cumbersome process. But think about in the days before computers and graphing calculators, that's what people with data and extrapolation and interpolation, that's what they did. You had to do it by hand, right? So it's pretty heavy math, but we're going to utilize the technology. So the idea here is we want to get this line as good as we can, right? And you can see mine wasn't all that great. So what I'm going to do, let me, whoops, sorry. I'm going to open that back up. What I'd like you to do is don't delete anything, but I'd want you to hide. I want you to hide the other dots and keep your A, B, C, and D, your blue ones, but hide like your G, H, F, blah, 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 and all that other stuff. So what I mean by hide is just click on the blue dot so I don't have to see it. Like I don't want to see E or F or G or H or K or L or N or P. Now I'm just back to my blue dots in my line. Are you guys there? I want to hide those dots because I'm going to show you how we can have the computer calculate this perfect line for us. And there's a couple ways to do it. Okay? The first way to do it, everybody ready? Go to your perpendicular line tool, parallel line, perpendicular bisector. See all those different lines that we can make? You should see one called best fit line. See that? And you can choose best fit line, and then you just got to kind of make a rectangle or a square over the points that you're interested in. So I'm going to start down here. I'm going to hold and click, and basically I'm going to make a window so that all 4 of my points, A, B, C, and D, are inside that window, and I'm going to let go, and it just spit out the line. Notice it's really close to that green line that I had on there, right? But it's not perfect. Now, Gage, when you did it, I bet that black line is almost laying right on top of your green line. If you had it down to 1.712. It's exactly the same. Yeah. So now, if I look at my green line, my green one was with these sliders. The slope is 0.542. The y-intercept is 2.356. I got that from these M and B sliders, right? But if I scroll down to the bottom of my page, it's telling me that the best fit line is actually 0.564, 2.152. And all of you should have got the exact same best fit because we all are working with the same 4 dots, right? So if I wanted to now, I could make my green line match up that black one. So the slope should be 0.564. I'm going to go to my M, and I'm going to change it to 0.564. And the other one, the y-intercept should be 2.152, so I'm going to change it to 2.152. Maybe. Yikes. Come on. 2.152. And now, notice what happened to my number. 1.712. That was as low as I could get it. Was everybody able to use that best fit box to get the line? Did that work for you? Just a side note before I forget, when we're doing these activities, we want to be able to attend to precision. We got to ask ourselves, how precise do we need to be when we are rounding, right? Like this doesn't even have labels. We don't even know what this data is. But if you're rounding in like dollars or something like that, or we're going to do one coming up with our project where we're going to look at mileage of a car. If you go to options and rounding, notice you can change the number of decimals. Right now I got it set to 3, but what happens if I wanted to see 5? Okay, well if I go to 5, now notice my best fit line. Well, now it's showing 4 here, 0.5638, 2.15235. We can see more decimal places if we want, right? So notice my 1.712 is now 1.7118, whatever. Okay, so that's how you can adjust the rounding. Now, there's another way to get that line. That line that we did at the bottom with that best fit tool, I'm going to delete it. I'm going to click on it and erase it like I never did it. The other way to get there is in the input bar, you can type the word fit, and notice all these different types of fit that you can get. Exponential, growth, blah, 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 logarithmic, logistic, polynomial. We'll talk about that in a second. But I think this is going to be a straight line, so I'm going to choose fit line. Fit line. And then it says, what points do you want? Well, points are always capitalized, and we're going to separate them by commas. I want points A, comma B, comma C, comma D. Wait a second. Did I do that right? I screwed something up. What did I screw up? Somebody help me.
Did you do a little like validator thing?
I better delete that. I wanted fit line, A comma, whoa, A comma B comma C comma D. Yeah, I screwed something up. It worked this time. Did it work? Did it give you that exact same line? There it is, 0.5638x, 2.15235. Okay, so the fit line in the input bar is exactly the same as grabbing this tool and just dragging over it and doing it, right? There's one other way that we can do this. And I'm going to delete this guy. Notice this is just giving us a line, a y equals mx plus b. I'm going to delete him. I want you to type in fit poly. Fit poly. That means fit polynomial. See that first one? Fit poly, list of points, and then it asks you for the degree of the polynomial. Well, a line is a polynomial. It's x to the first. What is x to the second? That's a polynomial, but it's not a line. It's a quadratic, right? A parabola. X to the third is a polynomial. X to the fourth is a polynomial. X to the fifth is a polynomial. So sometimes we might have data that isn't necessarily a straight line. Maybe we want it to be like a parabola, like a curve. We're not going to do that right now. But if you type in fit poly, and then the points are A, comma, B, comma, C, comma, D, comma, notice it's already defaulting to a third degree polynomial. See that red one? Notice it goes through all of the points, doesn't it? So it's a really good fit, right? But I'm going to go linear, so I'm going to go comma 1, because I want a first degree polynomial. So fit poly, A, comma, B, comma, C, comma, D, comma 1. And again, it spits out the same line, except this time it spits it out in function notation. But it's the same y equals mx plus b. So 3 ways to get to the exact same thing. I have no idea. Oh, you somehow put an oscillate on your B. Let's see if you can click on that guy. 1 second. If you right click on it, somehow you turn the animation on by accident. It should be fine now. Yeah. Okay. So now that we know how to find a fit, okay, a fit line, I'll give you one other one to practice. I'm going to be done with this one. On Blackboard, do you guys remember on the very first day of class when I showed you that data for how many times you're absent and what your grade is going to look like? I made a GeoGebra of that. Do you see that on Course Docs and Link? It's 1.7 absences grade. See that one? So this is the scatter plot. This is the data that we saw before when we practiced pasting it in to get the dots. So first of all, could you imagine trying to do this one by putting the little lines and adding up the squares? I mean, it was painful enough with 4 dots. How painful is it going to be with 27 dots? Or what happens if you had 300 dots? I mean, that would be miserable, right? You'd never want to do that. So we're just going to let the computer do the work here. So see if you can get a best fit line, a straight line for all of that data. Now, you could do fit line A, comma B, comma C, comma D. Yuck. You're going to have to type them all in, right? However, if you scroll down, notice all of these are in a list. It's L1. So you could go fit line L1, and it'll put all the points in there at once. Or you could use the tool where you just drop and drag a box over all of it. That's the one I'm going to do. So I'm going to drop and drag a box over every point. Boom. There's my line. Negative 1.79x plus 90.22. Is that what you guys got? Okay, let's do the same thing we did with the cell phone charge the other day. Let's actually analyze what that means. So the negative 1.79, put it in the context of what this is. What does it mean?
Average days missed.
It's not the average days missed.
Like points that go down. Points lost per day.
Points lost per day. On average, every time you miss class, you're going to lose 1.79 points on your total grade. Now, does that mean every single student lost exactly 1.79 points every time they were absent? Of course not. The only way that would be true is if every one of my points was exactly on that line, perfect. So this line is just an estimate, right? It's just an estimate. It's the best fitting line for this scenario. So what does the 90.22 mean?
Average grade.
It's not the average grade. I'm looking at my...
If they weren't to miss any class.
Yeah. If they weren't going to miss any classes, if they had 0 absences, because that's at 0, right? The y-intercept is at x equals 0. If they had 0 absences, you would predict that that student would get what for their grade? 90.22. That would be the rough estimate, right? So the reason we do this sort of activity, and this is what your project is going to be that I'm going to explain to you in a minute here. A lot of times what we do is we have data, okay? And we plot the data. Here I had, I don't know how many students, 17, 19, 20 some students, however many dots there are, right? Let's say that I had a student and I forgot to write down their absences and their grade. Like I totally left them off my list. And I'm like, oh shoot, how many times was that person absent and what grade did they get? I can't remember. But if I wanted to, I could make a rough prediction. See where I'm going here? Sometimes we have a bunch of data, but we want to produce more data from that data. We want to make a prediction. How do I make that prediction? I find a model or an equation that represents all the data, and then I use that equation to make my prediction. See where I'm going with this? Okay, so let's say I had a student that was going to be absent 12 times. A student is going to be absent 12 times, but I lost that person's grade, or I'm trying to predict what that person's grade would be. Can you make a prediction? And how would you do it? What do you think? Somebody's absent 12 times.
Find 12 and just go up to the line.
Yeah. Find out where 12 hits that line. So paper and pencil wise, I would plug 12 in where? In for x. I would take negative 1.79 times 12 plus 90.22, and I'd spit out some answer. Or I could do it electronically. Well, first I could just eyeball it. 12. Go up there. What's it going to be? About what? Yeah, a little less than 70, right? So I could eyeball it. I could do paper and pencil, right? Or I'm going to do what Will said. Watch this. I'm going to put in a line at 12. I'm going to just type in x equals 12. And it'll put in a vertical line at 12. I'm just using this line in the meantime because I'm interested in where it hits my other line, right? So now, do an intersection point where those two meet, and I get this new point V, some new point, and it says, I'm going to predict that a person who's absent 12 times is going to get 68.77 as their grade. Do we know for sure that's going to be their grade? Of course not. It's just a prediction, right? So can we go the other way? Let's say we knew the person's grade, but we were trying to predict how many times they were absent. Can you do that? So I'm going to get rid of this line that I just did. I'm done with him. Okay, let's say a person got an 82%. 82%. And somebody said, predict how many times you think that person was absent. What would you do?
Y equals 8.
Yeah, let's put in a line at 82, and then we'll do the same thing. Except this time it's not going to be x equals 82, it's y equals 82. Okay. I'm looking for that point right there, so I can figure out where those two cross each other, intersect. It seems to me, now I have a new point V, seems to me that person missed 4.6 classes. Whatever. Maybe they showed up for half a class one day. Or we just round. We use a little common sense and they said they either missed 4 or 5. Right? Comments or questions on that? We feel okay? Okay, there's a couple words that we need to learn, vocabulary, and they're fun to say. One of them is extrapolate. Let's say it together. Extrapolate. Extrapolate. The other one is interpolate. Interpolate. They're fun words to say. Okay? So when we extrapolate and when we interpolate. Extrapolate means we are looking for some prediction outside of our data. So to the left of our leftmost point or to the right of our rightmost point. So like our leftmost point are the people who missed 0, correct? So this would have no meaning in this context. It wouldn't make sense. But we could extrapolate to the left for somebody who missed -1 classes or -2 classes or -3 classes. Again, that doesn't make any sense, right? But that's any data we tried to predict over here would be extrapolate. But we could extrapolate the other way, right? My rightmost point is point G. This person missed class 22 times. Could we make a prediction? Hey, what do you think your grade is going to be if you miss 23 times or 24 or 25 or 26 or 27? See what that's extrapolate. It starts with EX because it's on the exterior, the outside of the data, exterior. Okay? So what is interpolate? Starts with IN. It's on the interior of the data. That's what we just did when we did 12 and when we did 82 because the points we got were on the inside of our data. Okay? Extrapolate, interpolate. Okay, last thing before I turn you loose here. or a couple things. One, there's what they call a correlation coefficient or a correlation of fit. Okay? Like how well does this line fit this data? So you might have, I think it's on page 49 of your textbook. I'm going to pull it up. You don't have to. You can just look at it on the screen with me here. Page 49. Hold on. Page 57, I'm sorry. 57. Okay, here are some examples of a bunch of dots that some are really, really good fitting lines and some have no correlation whatsoever, right? So notice the ones that are perfectly straight lines. Every one of those dots is in a straight line. So if you did a best fit line on that data, every dot would be on the line. It's a perfect straight line. So that person's correlation coefficient is 1.0, or you can think of it as 100%. Every dot was perfectly on the line. Okay? This one is also a perfect correlation, except it's -1 because it's a negative slope. Right? So a perfect correlation is 1 or -1. And every other correlation will be somewhere in between those two numbers. Okay? So this one, does it look like there's a trend going on? Yes, it does. It looks like the further right you go, the further up it's going to go, but it's not a perfect line, right? So notice it's a good correlation, like 80%, 0.8, but it's not great. This one even gets a little bit worse, but you still see that it looks like as you move to the right, it goes up. But when you get to this one, there's no correlation whatsoever. I could put a line anywhere in there and make you believe that that was the, right? And then, of course, more negative, blah, 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 and blah, blah, blah. So, and these, obviously, these would be a completely different set of whatever going on there, right? Like those aren't lines whatsoever. So the correlation of coefficient, let me show you how you can find it. I'm going to go back to that one that I had open earlier that just had my 4 points, my ABCD. This is the one we were practicing. Go ahead and type in correlation coefficient. Correlation coefficient. So I'm going to hit that, and then it says list of points. So I'm going to go A, comma B, comma C, comma D. And I'm going to hit enter, and it's going to tell me that my correlation coefficient is 0.94714. So how good of a fit is it? Pretty good, right? Like 0.94 is pretty close to 1. So the closer that number is to 1, or -1, if it was the other one, we'll do the grade one. The grade one will be negative, right? Because as we move to the right, it went down. So go to the grade one, the absences. I'm going to do correlation coefficient, and I'm just going to type in L1 because that's going to save me a ton of work, so I don't have to type all the guys in individually. Notice it's negative. We said it was going to be negative, right? Is it as good of a fit as the one where we just had the 4 points? No, because the other one was 0.94 and this one is 0.74, right? So when I make the argument, hey, look what happens when you miss class, your grade's going to go down. Is that a strong argument? Is it a weak argument? Do you believe me when I say that? You believe me at about a 0.74 clip. You're not 100% with me, but you're also not, you can see the correlation. It's just not ridiculously strong, right? Now, what happens if every one of these dots lined up in a perfect line? Then would you believe me that the more you miss class, the lower your grades are going to be? Of course you would. Because some people miss class and still got a good grade. Some people barely missed any class and still got a low grade. That happens, right? Okay. Here's where we're going to go. I'm going to give you something to look at. Matthew, you might want to look at this too. I'll wake him up. Tough morning in the lifting. Okay. Used car doc. See it? It's at the very bottom of Blackboard on course docs and links. So you're going to go through this whole process with your own data. That's your project. Okay? And I picked the topic of the project for you. Okay? So what we're going to do is you're going to make a scatter plot just like I made with the number of absences and the grade. But your scatter plot, each dot is not going to be a student. Each dot is going to be a used car that you found for sale online on cars.com or something like that. Okay? So what I want you to do is I want you to think about buying a used car. And think about what, like let's say hypothetically you were interested in buying a car right now. It's got to be a used one, and I'll tell you why. Think about what type of used car you would like to buy. And let's just pretend you have plenty of money. Okay? If you have two cars that are for sale, used cars, and they are absolutely identical, same color, same options, same everything, absolutely identical. The only difference between the two is one has 12,000 miles on it and the other one has 90,000 miles on it. Otherwise, they are absolutely identical cars. Which car do you think would cost more? The 12, of course, right? Anybody can tell you that in general, as a car gets more and more miles on it, the value of that car goes down, generally, right? Unless it's some kind of collector's edition, whatever. In general, okay? So what I want to do is I want you to think about what kind of used car you might be interested in buying, okay? 2012 Chevy Tahoe or something like that. Whatever you're interested in, okay? What I want you to try to do is you're going to go out and you're going to search for this used car that you're interested in buying, but I want you to search for the exact same car. So don't search for white ones and black ones and red ones. Pick a color, okay? Don't search for one that's 2012 and also a 2009. No, because that's going to change the price, right? Usually newer cars cost more, older cars cost less. Pick a year. Pick a car, pick a year, pick a color. Don't search for ones that one has leather seats and one has cloth seats. That's going to change the price, correct? Pick a trim level. I want you to try to find identical cars. Now, are they all going to be identical? Of course not. I want you to be as close as humanly possible. Okay? Try to find multiple cars for sale that are the same year, the same options, the same color, the same trim level, the same, except there's only going to be one difference that we're going to try to have as the difference between all of these cars, and that's going to be what? Miles. So when we make a scatter plot, we're going to have the mileage of the car I found and the price of the car that I found. And you're going to have dot, 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 dot. And all of those dots should be as close to identical vehicles as possible, the only difference being the mileage. Now, what should happen? What kind of trend should this show?
Higher miles, lower.
Higher the miles, lower the price. Is it always going to be perfect? Probably not, right? So, if you read through, I basically just told you what is on this document. Number one, choose a car. We just talked about that, right? Now you gotta, so record the car. Tell me the car that you're looking for. You're gonna have to type something in here. I want you to use this Word document as your template, and you're just gonna type all your data in here, and when you're done, you're gonna save it to your shared folder, okay? Number two, it says go to the internet, cars.com, Auto Trader, Car Gurus, Car Soup, eBay. These are places where you can find cars for sale, right? And I want you to search for that car. See what you can find, okay? And it says search within 500 miles of your current city. Do you think that makes a difference, by the way? Aren't cars priced differently in different parts of the country? Right? Okay. So read the directions. It says be sure to label your axes, blah, blah, blah. You're going to go through, you're going to find the best line of fit, and then you're going to interpolate and extrapolate as much as you can to come up with an argument. And I'm not going to read this whole thing to you. You can read the directions. But notice it goes all the way down to number 12. Okay? And then when I decide to give you a grade on this, let me just show you. If you go to, if you go to Blackboard, you'll see that this is a 40-point assignment, which is pretty big. And there's a rubric called Used Car. So here's what I'm going to do. I'm going to go through. Okay, I'm giving you a grade. Your Scatterplot. It was very much accurately labeled and displayed properly, or it was somewhat accurate and well displayed, or there's multiple display issues, or it was garbage. And I'm going to click on one of those point values for you. The trend line, the best fit line. Did you accurately calculate it? Or is it lacking accuracy, or is it bad, or is it non-existent? And I'm just going to go check, 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 check. So your goal should be for Jamie to go check, 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 check all the way down here, and then you get 40 out of 40. But that's how I'm going to give you a grade for this. So in the end, you're going to turn in two things. You're going to turn in the Word document, which is where you're going to type all of your stuff. Okay? Notice like on the last two items here, communications for items number 8 and 9. It was well explained. Your argument is easy to follow. It's backed up with evidence, and everything is accurately calculated. Okay? So that means you might have to type 2, 3, 4 sentences and explain yourself right inside the Word document. I believe it's going to be this because of this, and I found this, and when I calculated this, I got this, and that's why I think it's blah, blah, blah. Okay? So I'm asking you to construct a viable argument. Make an argument with evidence. This is what I calculated. This is what I found. Okay. So you'll turn in the Word document with all your content in it. You will also turn in the GeoGebra file that has your scatter plot with your axes labeled and everything like that. Not a snapshot of your file, the actual file. Because I'm going to go in there and I'm going to mess with your data and I'm going to do some calculations to see if you actually calculated everything correctly. Does that make sense? Okay, that's a lot. I've been talking a lot. Questions?
So we don't turn it anywhere, we just put it in.
It's going to be in the shared folder. Yep, it's going to be in the shared folder. And I'm going to give you some time to work on this. This isn't due on Wednesday or anything. I'll give you a week or so to work on this. But I want to use the next 20 minutes or 18 minutes of class so that you can get started. Okay, so just open up the Word doc, read the directions again really quick, read from the top, and hopefully in the class period today, you can start your search on AutoTrader or Cars.com or whatever you choose to use. Be a little bit careful if you're going to use multiple ones, because you might find that Pucklick Chevrolet at Valley City has a car for sale, and it's listed on both Cars.com and AutoTrader.com, and now you're going to have the same car, the same data point. So don't do that, right? Try to get different cars. Ideally, you should get 8, 9, 10, 12, 20 points, cars. Now, if you pick out the most rare Lamborghini 1987 blah, 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 you ain't finding 12 data points. So if you can't find the car that you're looking for, or you can only find 1 or 2 of them, and you don't have any other cars to compare it against, you're going to have to choose a more popular car, right? Not this rare, exotic, whatever car that you want to buy, if that makes sense. Okay.
What's the zip code?
This zip code is 58072. Business. Now would also be a good time if you have any questions on the cup stacking quiz that was bothering you. I can look at that with you as well if you want to choose to work on that instead of this. Late night last night, man? Early morning this morning? Looks like you need some coffee.
Yeah, we got back late.
We're-
We're still at homework.
You guys played? Not yesterday, did you? Oh, you did.
We had 2 on Saturday, 2 on Sunday.
Where were you guys at again?
We went to Dallas, Wisconsin.
We won the first 2 Saturday, didn't we? How'd we do yesterday?
Not as good.
Not as good. Did we lose both?
The first one we lost by a lot. The second one we were up 4-0 and we lost.
What time did you guys get home?
Like 11.
Okay. 1 second.
Yeah.
I'm just making one update to the Word document that you guys have open right now, and I'll show it to you really quick. I'm updating it on Blackboard. So if you already typed a ton of stuff in there, I apologize. You'll have to copy and paste quick. The update that I made was on number 4. On number 4, asked you to give the equation for the best fit line. Record your equation here. I put in a 4a where it says find the coefficient of fit. Remember we just did that? Find the coefficient of fit, record that coefficient of fit, and then explain what that coefficient of fit means. I didn't have that in the original document, but now that's there. Okay.
I got 1, 2, and so it's weird. I got 4 right. So based off getting 4 right, why would I not be able to figure out the height and how many
So,
cups the blue?
okay, so for number 3, scroll up to number 3 once. What did that one ask? If we continue, did you get number 3 right?
Nope. I got
So-
3, 5 now.
Okay, so where's your computation for
Network.
Yeah.
Oh, sorry, it's kind of on a
Well, there's your first problem.
piece of paper.
Okay.
120.74 centimeters.
Okay, so these are your 2 equations from the first guy, which are correct, right?
Yep, yeah, those
Yep.
are correct. Yep.
Okay, so now, so the blue's going to have 50 cups. So that's going to be, at the start of the race, the blue is at that, right? Because
Yeah.
they already have 50.
Yeah.
And the white is at what?
Well, when they're equal, white, which I got right, is at 87 cups.
Okay, but that's not what the question's asking.
Huh?
The question is saying the blue cups have 50 and the white cups have 1.
Yep.
So obviously blue is way ahead.
Yep.
Now go 51 to 2, 52 to 3,
Yep.
53 to 4, okay? So you're saying
when you get
when you get to 87? How did you get that 87?
Huh?
How did you get that?
Let's look here quick.
Okay, first of all, I think I already
I used 120, so how is that right if that's wrong?
So let's go back to the 120.
Okay.
You're telling me that 50 cups is going to be
120.74 centimeters off the ground. And where I'm confused is I used that number here, and I got the right answer for number
Okay.
4. So how could number 3 be wrong and 4 be right?
Okay, hang on 1 second.
I must just my writing must be wrong or something.
You've got so many attempts at this that I can't even look and see what you did. Okay. So you're for number 3. Your number 3 is not correct. It's not 120. You made a mistake there, and the reason I think you made that mistake is if you go back to your original equation,
Yeah.
you're saying it's 0.8x plus 11.3. So how tall is 50 cups going to be?
51.3.
Yep. And how tall? So what did you do with that 51.3?
That I actually don't remember.
You're really close. You're like a couple cups off.
Because I mean 87, how is that right? And that's not when I'm using 1.7.
So, and part of it is because I gave you a leeway of plus or minus 1 cup. Yeah. Technically 87 isn't correct either, but you got it within the range of what I gave you for estimating. So what you're missing here is, there's so many different ways to look at this, but if the blue is sitting at a height of 51.3,
Yeah.
the white is currently sitting at what, when there's only 1 cup? I think what you're missing is the difference between like 1 cup and 2, because we don't start with, if this is the equation for the white,
Yeah.
like if you put in 0, it would say 7.9, but we know that's not true, right?
Yeah.
Like you got to start at 1 cup. So like how tall is 1 white cup? 9.2?
Yeah, 9.2, yep.
So currently blue is sitting at that.
Yep.
White's sitting at 9.2. If I subtract that, blue currently has a head start of 42.1, but the white's going to catch up.
Yep. So this is 87 cups is technically not.
87 is actually wrong. So if I put in 80,
Okay.
if I put
So
in
that's where the
87
issue is.
cups, so where's is it 1.3?
Yep.
1.3 times 87 plus the 7.9, I get 121. And if it's going to be 87 white cups, that means we would have added 86 to the pile.
Yep.
So we also added 86 to the blue pile, which gets me up to what? 50 plus the 86? Because we add 1 for 1. So that'd be 136 blue cups. Okay.
136.75.
Times.
So I rounded that up to 137.
Okay, so if I go times 0.8 plus 11.3
So I was off by like.
plus 11.3, I'd be at 120.1, whereas the white's at 121, so we're still a little bit off. You're really close. I think you're missing it by 1 cup or with the
Yeah,
rounding or
something
something.
like
If I were you, I would plot it on your GeoGebra and actually look at where the 2 lines are going to hit. But there's like 3 different ways to do this, depending on what order you want to go in, and that's why it's a difficult.
Yeah, it just confused me because I had 4 right, but
Right.
5 are wrong. So all right.
And you were jobbing the system by getting purposefully getting a 0 on the other ones, so you could see which ones you got right and which ones you got wrong. So I like your cleverness. Okay, we are out of time, so you are free to take off. Otherwise, come see me if you have any questions or anything. Otherwise, we'll see you on Wednesday.